Okay, so we did problem number 6, and 6a states the number of bacteria in two colonies A and B starts increasing at the same time. The number of bacteria in colony A after t hours is modeled by the function a to the t equals 12 times e to the 0.4 t. Find the number of bacteria in colony A after 4 hours. But this is the same question as problem number B, so we're going to start by finding the number of bacteria in colony A after 0 hours in order to find the initial amount of bacteria. So in order to find A of 0, we need to plug in 0 for t, since t is the time and the time is 0 hours in the beginning. So A of 0 equals 12 to the times e to the 0.4 to the 0, which equals 12 times 1, and which equals 12. So the answer is 12 bacteria, which is the initial amount.
Question 6b asks us to find the number of bacteria in colony A after 4 hours. So because we're asked to find the number of bacteria and we're given that the time is 4 hours, we know that t equals 4. So then we'll set up our equation equal t to 4, and we will have A4 equals 12e to the 0.4 times 4. And then when you solve that, you get A to the 4 equals 59.4. But we're going to be rounding to a whole number, so we're going to be rounding down to 59. So we know that there's 59 bacteria in colony A after 4 hours.
Problem 6c asks us to figure out how long it takes for the number of bacteria in colony A to reach 400. Since A of t is representative of the number of bacteria, we can substitute 400 for A of t and set the equation 400 equal to 12e to the power 0.4 t. Because we set these two equations equal to each other, we can graph them to figure out t, which is what the question asks. 400 is y1 equation, and 12e to the power 0.4 t is the y2 equation. When we graph, we will have to change our window and change y max to equal 500 in order to see the line y equals 400. The first line being graphed right now is y equals 400, and the second line being graphed is 12e to the power 0.4 t. Now we find the intersection normally and the x-coordinate represents our answer because time is represented on the x-axis, and that's what we're being asked to find, the time it takes for the colony A to reach 400. And therefore our answer is 8.77 hours.
Problem 6d states the number of bacteria in colony B after t hours is modeled by the function b of t equals 24e to the kt. After 4 hours, there are 60 bacteria in colony B. Find the value of k. So since t equals 4 hours and b of t equals 60 bacteria, we can plug 4 hours in for the t to get 24e to the k times 4. And this equation is going to be our y2 equation that we will be plugging into our calculators, and b of t is going to be y1. When putting these two together, we're going to graph them in order to find the point of intersection to find the value of k.
In order to graph problem 6d, we're going to plug 60 in for y1, and then we're going to put 24 times e to the 4k in for y2. Then we're going to change our window to equal 150, and then graph. In order to find our answer, you do second trace, intersect. So you can find this one of two ways. You can scroll down to intersect, or you can just press 5. And then we'll find that our answer is 0.229.
Some 6d reminders are that k does not have any units because it is a constant like r, and we can still graph the two equations in 6d to find the answer because now the k value represents the x value. For 6e, we are trying to find when the number of bacteria in colony A exceeds the number of bacteria in colony B. Therefore, we can set the equations for colony A equal to colony B, where colony A is A of t equals 12e to the power 0.4t, and colony B is B of t equals 24e to the power 0.229t. We use 0.229t for k because we found that constant in 6D. Because we set A of t equal to B of t, we can graph them to figure out how long it takes for A to exceed B. We put 12e to the power 0.4t, which is colony A, for y1, and 24e to the power 0.229t, which is colony B, for y2. Therefore, the first graph you're seeing is for colony A, and the second graph you're seeing is for colony B. As you can see, before the intersection point, colony A's line is below colony B's line, indicating that the number of bacteria in A is less than B. However, after the intersection, colony A's line is above colony B's line, so we have to find the intersection in order to find when colony A exceeds colony B, which is what we're being asked to find. We use the x value of the intersection because we're looking for time, and time is on the x-axis. The x value is 4.05, but we must round up to 5 because we are looking for an integer, which is what that symbol means in the problem, the z symbol. And so we round up to 5, but we do not round up down to 4 because at 4 hours the colony A is still below colony B.